So in this video we will be talking about propagation of electromagnetic waves. There are different waves depending upon the frequency or the wavelength of the waves. It can be propagated differently. So let's start with your ground wave propagation, that is ground wave. This is my first one, that is ground wave. So what actually is ground wave? As you know, in your ground, say suppose this is the surface of the earth. This is the surface of the earth. In your ground you have antennas. This is the antennas. Now this can be propagated only for a short distance because of the curvature of the earth. So suppose another antenna is over here. Now please keep in mind, if you're traveling by ground wave, it will somewhat go in a straight line. It will somewhat go in a straight line. It won't be affected by the magnetic field of the earth because the pulling force of the earth's magnetic or the gravitational force is quite less. So that's the reason why I said this should be in a shorter distance and this should be a bit high. The height of the tower should be approximately in the lambda, or at least it should be 1 by 4th of the wavelength, the height of the tower. This is the height. We are talking about the height. So now if you look or notice, if this particular antenna was somewhere over here, say at a greater distance between these two, so we would have noticed that the wave had gone in this way. So it should be at a shorter distance and it is travel parallel to the surface of the earth. And the best example is your AM, amplitude modulated wave. AM, that is your radio waves, the radio which you listen to. This is being transmitted by AM. This is amplitude modulation, and this particular or this type of propagation uses the ground wave way of sending or transmitting the wave. So now in this type of wave, when we know that from ground wave, if the frequency has increased to around 1 megahertz to around 30 to 40 megahertz, say suppose this is a frequency. Now it is not possible to send this via ground, or it is not feasible, you can understand this. So what we can do is, we know our earth's surface is covered by ionosphere, that is a charged particle that when it comes from the sun it is scattered. So there are charged particles which is known as ions are there, and this layer of ions is known as ionosphere. So this layer is there in our earth's atmosphere. This is known as ionosphere. So what we can do is, we can direct this ionosphere and we can target this reflection to a particular point. So this targeting and reflection of wave via the ionosphere, when the frequency is of this range, is known as your sky wave propagation. This is known as your sky wave propagation. Now another type of communication that you want to know is about space wave. So when you talk about space wave, you need to know that, say suppose this is a surface of the earth. Now these are two antennas. At a height h. Now there are two ways in which you can communicate. One is via a satellite. So this is your atmosphere and this here will be your satellite. So this is your satellite. So what we do is, we direct the signal or the information over here, and this satellite receives this and it reflects back the information to your receiver somewhere over here. So that is, you are traveling through space. Another way of communication is also known as the line of sight. Also, this is where in a book you will see this line of sight. Line of sight actually means that even though you cannot comprehend this with your naked eye, but if this is forming if these two antennas are in your straight line, that is in your line of sight, then we can communicate through this. And this type of communication, line of sight, is also known as LOS communication. Communication. So what is the criteria? What is the criteria for this line of sight? Is that, say suppose you know this distance d. You know this distance d. This is the diameter or the radius of Earth. If this is the radius of Earth, this is the radius of Earth, and this is the distance d. This is the distance d, and this is the height h. So it is given by d. The distance d is given by root over of 2 r into ht. So this is the, therefore the diameter dm is given by root over of 2 r ht plus root over of 2 r ht. Well, what is h? Now we have established that h is the height of the antenna. Now we can show that the distance to the horizon dt. This is the distance to the horizon. What is the distance to the horizon that we are looking into? That is, your dt is given by, where r is the radius of the earth. Now this r is the radius of the earth. So by using this formula, we can straight away write. Now if you look at this, compared to this to this height is very small. This height is very small. So if you look at d, this is the distance, and if you look at the radius r, this is the radius of earth. So this is another way of communicating through space wave, and the diameter is given by dm is equal to twice root over twice rh plus root over twice rh. So now what does this calculation tells us about? What does this actually, what is the purpose? Now if you look at this, what is the maximum height? If you want to see what is the maximum distance? What is the maximum distance of the horizon where you can transmit signals if you have a height of h? If you have a height of h, what is the maximum distance that you can transmit your signal? So that is given by dm is actually given by root over of 2 r h t plus root over of 2 r h r, where this is the height. Ht is for transmission and hr is for receiving. So this is the maximum horizontal height for which you can transmit your signal. Say if this is bigger, if you keep on increasing, this will also keep on increasing. So this calculation was all about what will be the maximum transmission length or distance for a given height. Now this transmission will depend both on this and this, and independently on this and independently on this.